So if you notice, ladies and gentlemen, on the note packet that for Chapter 6, you see some formulas or co-function identities that I have printed at the top. And next to it, I wrote a keyword that should look familiar to you called complementary. What does it mean when angles are complementary? Let's refresh our memory from geometry a little bit. What complementary angles do what? Add up to equal 90 degrees. So again, remember, complementary angles add up to equal 90 degrees. So before I jump into the notes, this will help, I think, introduce the idea of co-function identities. So let's talk about the cosine of 60 degrees for a minute. From the unit circle, what is the cosine of 60 degrees equivalent to? We're in quadrant 1, so we know it's positive. From the unit circle, cosine of 60 is 1/2. Let's talk about the sine of 30 degrees. Tell me about the sine of 30 degrees. 1/2. What do you notice about 60 degrees and 30 degrees? They are what? Complementary. Sine and cosine are what are called cofunctions. So think of that prefix CO with complementary. So notice 60 degrees and 30 degrees are complementary angles. So by understanding the relationship that sine and cosine are cofunctions, what that means is that if you have the cosine and sine of two angles, and these two angles are complementary, their outputs are going to be exactly the same. So for example, if I look at the sine of 45 degrees, sine of 45 degrees is what? Square root 2 over 2. Cosine of 45 degrees is what? Square root 2 over 2. What do you notice about these two angles, 45 degrees and 45 degrees? They are what? They are complementary. That's how the cofunction identities work. Sine and cosine are cofunctions. So meaning right here that, remember, pi over 2 is equivalent to 90 degrees in radians. So the sine of 90 degrees minus some angle is going to be equal to the cosine of whatever this angle is going to be. Vice versa, the cosine of 90 degrees minus this particular angle will be equal to the sine. So sine and cosine go together with your cofunctions. Secant and cosecant. Well, that makes sense since secant and cosecant are reciprocal of the sine and the cosine. So secant and cosecant are also cofunctions of one another. Tangent and cotangent go together as well, are cofunctions. So for example, if you look at the tangent of 60 degrees, or we know 60 degrees is equivalent to the tangent of pi over 3. So what is the tangent of 60 degrees, or what is the tangent of pi over 3? Square root 3. Well, what's the complement to 60 degrees? The complement to 60 degrees is 30. So then tangent and cotangent are cofunctions. So the cotangent of 30 degrees is also going to be, again, you could look at the cotangent of pi over 6 if you're in radians, would also be equal to the square root of 3. Okay? So again, you're just looking at different ways to evaluate expressions, especially when you're dealing with angles that are not on the unit circle. So that's what these cofunction identity formulas represent up here. So just remember the prefix CO, complementary. All right? So before we get into the cofunction identities, again, rounding to 3 decimal places always. You guys were talking about in the first section of this unit right triangle trigonometry. That's what we've been studying pretty much all semester. Let's take a look at this particular triangle. They want you to find the exact value of all 6 trig functions for your angle theta. So that means we're looking at SOHCAHTOA. Again, remember your SOHCAHTOA. And the 6 trig functions would also include the reciprocal functions. By the way, is the side of this, before you set up your 6 trig functions, you have to know all 3 sides of the triangle. Is this side of the triangle 5? No. Be careful about that. How come it can't be 5? Hypotenuse has to be the longest side, so you can't have a side longer than the hypotenuse. How are you going to find the third side of this right triangle? However, you can use your what? Pythagorean theorem. So 4 squared is equal to 3 squared plus b squared. So I'm going to call this side b. So I have 16 is equal to 9 plus b squared. How do you solve for b here? Subtract 9, so 16 minus 9 is 7. So how do I solve for b? I'm going to have to do what? Square root. So b is equal to the square root of 7. So like I said, before you set up your trig ratios, make sure you know all three sides of the triangle. Again, theta is your reference point in this triangle. So I want to find the sine of theta. Remember, sine is the opposite over hypotenuse. So what is the sine of theta going to be? The sine of theta will be what ratio? 3 over 4. And what I always do is just go ahead and I find the reciprocal, so the cosecant of theta would just be 4/3. So next I'm going to set up the cosine. By your SOHCAHTOA, remember cosine is the adjacent over the hypotenuse. So what is the cosine going to be? What's my adjacent side? Square root 7 over 4. Then the secant is going to be the reciprocal of the cosine, 4 over square root 7. Again, rationalize that denominator, so that's going to be 4 square root 7 over 7. Okay. Last one is the tangent. That's your TOA. Remember, tangent is the opposite over adjacent. So the tangent's going to be 3 over square root 7, which rationalizes 3 square root 7 over 7. And then finally, the cotangent. Now remember, when you go to set up the cotangent, guys, don't use the version of the fraction that you rationalized. Use the one that you set up originally using the opposite over adjacent. We had 3 over square root 7. The reciprocal of 3 over square root 7 is simply going to be the square root of 7 over 3. So any questions given a triangle, how you can set up the 6 trig ratios? All right. So now find the exact value of each expression. Again, this would be really the only problems in this unit that you'll not have a calculator for. Tangent of 12 degrees minus cotangent of 78 degrees. Again, 12 degrees and 78 degrees are not the special angles from the unit circle, so this is where I know I'll be looking at the identities. But now look at 12 degrees and look at 78 degrees. What is the relationship between those two angles if I add together? They are what? Complementary. So then what I know is that the cotangent of 78 degrees has to be equal to the tangent of whatever the complement of 78 degrees is going to be. So the cotangent of 78 has to be equal to the tangent of 12 degrees. Because the idea what you want to be able to do at this point is rewrite the expression with just one type of angle and hopefully be able to do some simplifying that way. So it's kind of an eeny, meeny, miny, mo. Change everything into tangent, change everything into cotangent. That's completely up to you. So I can replace cotangent with the cotangent of 78 degrees. So the tangent of 12 degrees is equal to the cotangent of 78 degrees. And now I can simplify that. What is the cotangent of 78 minus the cotangent of 78? 0. So that's how you use the cofunction identities. So let's take a look at number 3. You have cosine of 40 degrees divided by the sine of 50 degrees. Again, this is not a calculator question. Again, what's the relationship between 40 and 50 degrees? What are they of one another? Complementary. So that's an idea that you're going to use your cofunctions. So I know that the cosine of 40 degrees is equal to the sine of the complement of 40 degrees. And the complement of 40 degrees is 50 degrees. So what I can do then in this expression is rewrite everything in terms of cosine or rewrite everything in terms of sine. So I can change cosine of 40 into sine of 50 degrees. So then sine of 50 degrees divided by sine of 50 degrees. And what is the sine of 50 divided by the sine of 50? 1. Okay. So now let's take a look at the next one. 1 minus cosine squared 20 minus cosine squared 70 degrees. Right here I'm kind of stuck. I can't do anything with these cosine squares because they are different angle measurements. But now look right here. this 1 minus cosine squared is equivalent to something by a Pythagorean identity. What is it equivalent to? It's equivalent to what? Sine squared. Again, that's your Pythagorean identity. Now, so sometimes you may have to use another identity before you get to the cofunctions. So now look at the 20 degrees and 70 degrees. What do you notice about the relationship between 20 degrees and 70 degrees? What are they of one another? Complementary. So then I know that the sine squared of 20 degrees is equal to the cosine squared of the complement of 20 degrees, which is 70 degrees. So just like I did, it's an eeny, meeny, miny, mo. You can change everything into sine squared, or you can change everything into cosine squared. So again, sine squared of 20 is equivalent to cosine squared of 70 degrees. So I can change my sine squared of 20 into the cosine squared of 70 degrees minus cosine squared of 70 degrees, and that's going to be equal to 0. I know a couple of you that were working on the midterm review number 1, I believe, had questions like this, and I said you're going to get to it when we get to chapter 6, unit 6. All right? So any questions on that? So again, a red flag that you're going to be using some kind of cofunction identities is you look at the angles and you see that they are complementary angles. Okay? So not only, ladies and gentlemen, that you can use now SOHCAHTOA to set up trig ratios, we can also use SOHCAHTOA to help us solve for missing angles within a triangle. Now that we understand what inverse functions are, we can use SOHCAHTOA to help us solve for angles. So notice they're giving me a triangle. So again, just so you know, lowercase letters are sides. In this chapter, the lowercase letter will be sides. Uppercase letters, when you see them, will be equal to your angles. And again, a lowercase a, uppercase A, that would be the side opposite angle A. So in this particular triangle, they're telling us that side A is equal to 7. Angle B is 50 degrees. They want us to find side B, side C, and angle alpha. Well, first of all, remind me again, what do all three angles add up to equal in a triangle? 180. So that I know that alpha has to be equal to 180 degrees minus, I know, 2 of the 3 angles in this triangle. By the way, this is a right angle, so what's the right angle measurement? 90. So if I take 90 and add it to 50 degrees and subtract that sum from 180, I'll be able to find angle alpha. So what's angle alpha going to be equal to? 40 degrees. Okay? So if you know 2 of the 3 angles within the triangle, you can just add them together and subtract from 180 to find the third one. So now, can I use my Pythagorean theorem at this point? No. How come I can't use my Pythagorean theorem? I have to know how many sides in order to use Pythagorean theorem. 2. I don't have to know at least 2. I only know 1. So this is where I can set up my trig ratios. And again, it's kind of an eeny, meeny, miny, mo. I'm going to use angle B as my reference point. And what I'm going to do is I'm going to find side B first. It doesn't matter what side you find first. You could certainly use C. So in relationship to my 50-degree angle, is side B the hypotenuse? Is it the opposite or is it the adjacent? Opposite. In relationship to angle B, what is side A? Is that the hypotenuse, opposite, or adjacent? Adjacent. So what trig ratio comes to mind when you have opposite and adjacent sides? Tangent. So what I'm going to do is set up my tangent ratio. So I'm going to take the tangent. I know the angle is 50 degrees. Equals the opposite over the adjacent. Remember, I'm trying to solve for B. So now I've set up an equation. How can I solve for B? I can multiply both sides by what? 7. So B is going to be equal to 7 times the tangent of 50 degrees. Now I know in our calculators we have been in radian mode quite a bit. In this unit, all of our angles are going to be mostly in degree mode. So make sure on your calculators we go ahead and change your mode to degrees. The angles given to you in degrees, make sure you are in degree mode. So now to find side B, all I'm going to do is type in 7 times the tangent of 50. And that gives me about 8.342. Always round to, remember, 3 decimal places. Okay? So now I know the second side of the triangle. When you are setting these problems up in this unit, I'm going to emphasize this over and over again. Always use the information given. This is a rounded answer. I still have one more side to solve. So we want to avoid using this 8.342. If you use a rounded answer to calculate another rounded answer, you're going to get further and further away from what the actual value of that side is going to be. It's always better to use the information given. So I'm not going to use Pythagorean theorem to help me find my third side of the triangle. Again, I was given side A. We already just talked about in relationship to 50 degrees, A was the adjacent side. What is side C in relationship to 50 degrees? Is it the hypotenuse, opposite, or adjacent? Hypotenuse. So what trig function comes to mind when we're talking about adjacent and hypotenuse? Cosine. So now I can set up the cosine ratio. So the cosine of 50 degrees is equal to 7 over C. Now sometimes it may take 2 steps to solve the equation algebraically. So my first step to solve for C is going to be to do what? Get C out of the denominator, so I'm going to multiply both sides by C. So C times the cosine of 50 degrees is equal to 7. Then what? How can I get C by itself? I can do what? What can I do? Divide by cosine 50. So I can type that in my calculator. So I have 7 divided by the cosine of 50. So we have 10.890. Yes, you have to write that 0. That shows that it is rounded out to 3 decimal places. Okay? So any questions on how you can use the trig ratios to help you solve for the sides of a particular triangle? Okay? Just a review from geometry. You guys talked about angle of elevations and angle of depression. So we're talking about line of sight in relationship to the horizontal. So the angle of elevation is the angle between a horizontal line and another if the line is above the horizontal. So right in here, the dashed line is my horizontal. This is my angle of elevation. The angle of depression is the angle between a horizontal line and another line if the angle is below the horizontal. So right in here, again, the orange line is my horizontal. Then this is going to be my angle of depression.